As we get into the simplification of more complicated expressions involving rational exponents, it's worth taking a moment to pause and consider an important distinction that was made in Algebra 1 that reappears here in this lesson. So the distinction that I'm talking about is the difference between this expression and an expression that looks like this. In this first expression, you covered in your Algebra 1 experience that you would only square the x. The 2 is directly adjacent to the x. The 5 that was first was a separate multiplication. And obviously, we're just going to rewrite that expression as the easiest way to write it. In the second expression, we see how the 2 is directly adjacent to the parentheses. That 2 is applying to both of those terms on the inside. So what is actually being squared is the 5x. We're getting a copy of 5x multiplied by itself. If I was to simplify that a little bit further using the commutative property, I'm going to change the order around a little bit, and I'm going to end up with 25x squared. So you can see that there is a clear difference between having the parentheses and not having the parentheses. We ended up with an extra factor of that first constant coefficient. That same principle applies when we're working with fractional exponents. So, working with fractional exponents, let's first give the consideration to an expression that looks like this. Because that 3/4 is directly adjacent to the y, that fourth root of y cubed is only applied to the y. In the event that a parentheses is around the expression, that fourth root of the cube applies to both the 8 and the y. You can see now how that 8 is inside of the parentheses. Now, we've seen elsewhere in this lesson that we have some other options when it comes to writing this expression. We could write the expression like this, where we end up cubing the entire thing. But in an ideal world, we're not going to have any kind of parentheses in our final solution version, our final simplified version, excuse me. We're going to try to clean up as much as we can. That's where we remember the other rule for parentheses, and namely the situation where we have a power raised to another power. This 3/4 can be applied to both of those factors individually. So instead of trying to apply the cube to 8y or to the fourth root, we can apply that cube and that fourth root to each of those factors separately. So it would look like this. We have the fourth root of 8 cubed and the fourth root of y cubed. This right here jives nicely with what we saw previously. It's this where we run into a little bit of trouble because we really want to evaluate that. That is a big, gnarly answer that we really want to try to figure out. The truth is that sometimes you'll be able to, and sometimes you won't. This is a situation where you're not able to. 8 to the third power is 512. The fourth root of 512 is a number that's 4.7 something. That is irrelevant to the question. The more relevant point is that this is not something that is easy to evaluate. In those circumstances where you think you can evaluate it, however, you want to keep in mind that you have two options in terms of how you write that. So you had this fourth root of 8 cubed. But we know, based on our experiences with the commutative property and what we saw elsewhere in this lesson, that that is equivalent to this. Or if you prefer to not write it with the parentheses, this is not ideal, but you could write it like that. It's a very sloppy way to write it, but you could write it like that. If you wanted to reorient the fourth root and the third root, or the third power, and not have them go in order of root power, you could go, instead of going power root, you could go root power and have the root taken first and then execute the power. That is an option. That won't help us here. The fourth root of 8 is not something that we are capable of evaluating. That's again a decimal raised to the third power, again a decimal. So in this particular circumstance, it doesn't help. But just remember that you have that option. You have the option to either execute the root first, or you have the option to execute the power first. And in terms of how you write it, 99% of the time, this is going to be fine in terms of how you write it, and this is going to be okay in terms of how you write it. But if this is something that you think you might be able to evaluate if you do the root first, then it's worth checking to see if you could simplify it further.